talking about Incenter, Circumcenter, all that stuff, but I don't remember us doing it.
I won't be helpful at all for this.
Okay, but you saying that you're not going to be helpful doesn't help anything, obviously.
Therefore, I'm not being helpful.
Oh wait, I was.
So, Satya, my advice to you would be watch the video from yesterday. Check some resources. Check your math notes box here for all these points of concurrency. I don't even know how far we made it. Did not even start 4, I don't think.
Oh yeah, is there math notes on the computer thing?
Not on homework help. In the ebook, yes. The ebook is exactly what I'm in right now. So aside from the fact that I have tabs that you guys don't have, the entire section is in the ebook, including the math notes box.
Wait, that's not what mine looks like.
Yes, it does.
Yeah. I was like, look.
You're in the homework help, not the ebook. No, okay, bro. Yours looks like this. You hide the toolbars to make it full screen. Because if I zoom like this was really bad coding. The sidebars zoom also. They should have made the code that the sidebars don't zoom. But I don't know if you can actually write a code like that, because this zoom is controlled by the internet window. They did make their text move on the zoom, which is awesome. Other pages, it just zooms and the text doesn't actually move, which is really annoying.
And it looks really weird.
All right, so we now, did we do the Centroid yesterday? Did we do 3? Okay, so let's remind ourselves, even if we don't do this particularly, and we might at some point do a little lab and actually, we talked about doing this with cardboard.
Where a compass?
Over there, because I only have an outlet.
Where do our compass?
This is day 1 of it.
Can you give me one? Thanks, man.
Wow, Satya, you beat up your laptop.
What?
Dropped your laptop on a corner.
No, we got it for cheap because it was broken.
So, the centroid, we said, is the point of concurrency between what lines? All the medians, right? So all the medians, we find the midpoints, which to remind ourselves how to find the midpoints. So yesterday, you should have on the back of your paper just a random triangle drawn. Well, we use those other ones for other things, so hopefully you'll just still be able to. How do we find the midpoints? Hunter, you look forward. How do we find the midpoints?
I think I know this.
Anyone else need a compass while I'm over here?
I need a rule. Yeah, I need a new compass.
Mr. Hudson.
For midpoint?
Yeah.
Yeah, how do you find it? This?
So you put your compass or the point thing of the compass on one point. So you put the pencil on another point, and you just make a giant arc that roughly goes through.
So the more, no, you're right. The more you do this, the more comfortable you're going to get. So that's why, no, you can't come up here because I want you doing it on your paper.
And then
as Satya is saying, he's absolutely right.
And then you put the stabby thing on another point, on the point that you put the pencil on, and you kind of switch the roles. And you make
now, hold up. I'm going to make your life easier. From here, if I could utilize this arc for 2 arcs, my life's going to be easier, right?
Yeah.
Then I can do it from here and my base angle.
And then you just take a straight edge.
And actually, if it does all of them, I could use this for all of them, potentially. It will look sweet, like we're going to do with my math art class. My one arc wasn't big enough.
I'm doing the candy making thing.
So, I end up with this.
What?
They're midpoints. Remember, they won't be
yeah.
perpendicular because they're midpoints. So that whole like grab a straight edge, I would not necessarily. You don't want to draw this line.
Well, yeah.
Nice. You don't want to draw this line. You just want to mark the midpoint.
Yeah, we're doing equal lines.
Biohazard.
I didn't make an equal. I just drew a triangle. It might be equilateral. I don't know. This, don't draw the line because it doesn't go to the vertex.
Wait, are you finding the centroid or the midpoints of each one?
Finding the midpoints first because, yeah, to find the centroid, you need the midpoints.
Okay, so then, okay, you are doing it right. Never mind. Steven had me confused because he.
Don't draw the line, just find the midpoints. Then connect the vertex to the midpoint.
I feel like every day I leave, we do something important.
Well, quit leaving.
We do important things every day, Satya.
I can't control when
roasted.
my body decides to be anxious.
Is that what being sick is? Just your body's.
So as Jacob said yesterday, we shouldn't need all three lines. The third line checking your point of concurrency is verification that we did it right. So notice my first two lines have an intersection. My third line should hit that same intersection. And this is my centroid.
Wait, why would you have a straight edge but not a ruler? Why could you don't
Are
even
you
have
kidding? Think back to like the 12th century.
Yes.
How easy do you think it is to make things perfectly marked at 30 seconds of an inch apart?
But
Very easy.
no, you could
32
just
7 inches.
you could just make up a unit.
32.
Like
That's not
say
how that works, 'cause
this
that's-
one rock.
You're right, but then your rock isn't the same as my rock.
No, yes, I'm talking about for one specific project. Like how that's why we had to set.
You're
limits.
100% right. I didn't say there weren't marked measurements. I said we didn't have rulers. You could say this length from here to here is 1 quiz bit, and I'm going to measure everything using quiz bits.
Yeah.
You could, yes, people did that, but there was no standard of there weren't like I walk to ye old hardware store and
Yeah.
buy a measuring tape. Like
Yeah.
that didn't. No. Can we move on instead of arguing these things? 'Cause I would like to get you your test back today.
Oh yeah, we can move on.
Centroid, center of weight, right? Centroid is center of mass. So now we can use our resource page again. So I'm flipping this. Circumcenter.
Is there like an easier way to define centroid?
I mean, this is it.
No, what do you mean like center? I don't understand.
So literally, if I cut that triangle out, put a pencil on the point, it would balance. It's the center of weight. There's equal weight going every direction. Yeah, kind of crazy. Try it. Use a triangle, like make a triangle with something like rigid, like cardboard or something. Cut it out, find all your medians, it will balance.
Like actually?
Yeah, it's math. What do you mean actually?
Oh, okay.
I didn't become a math teacher to lie to kids.
Actually, no.
You never know.
That's another lie right there.
All right, so circumcenter, the circle is going to circumscribe in 8-4 on your resource page. Let's make our circumcenter, by connecting what? Perpendicular bisectors. How do we find the perpendicular? Oh, crap.
Can someone help me with
Don't
this?
we do what we just did?
Like this, right? This circle around the thing.
So wait, if I think back to what we just did, how would I change this process? Instead of marking the midpoint and drawing it, you actually follow the intersections. That's going to be my perpendicular bisector. So in a different color, I'm just going to do that back here.
Yay, I did it. And then how do you do the incenter?
Dude, 1, you're ahead of me. 2, we talked about this yesterday. 3, it's in your book.
Nice, Thomas.
This is the only straight.
I'm getting one of those too.
This is the only straight.
There are also the blue little tools down by where the compasses were.
Or you could just use a textbook.
It's just a giant ruler.
This is more fun. Guys,
Or
paper.
yardstick, whatever it is.
Lots of things are straight edges. I used to use my cell phone in college if I had nothing else.
God.
Yeah, but you can't do that.
Hot rip. Oh, I get it. You make a triangle.
Yes, I'm
How come you
using
can't
my
have phones in
findings, and
Phoenix?
no, I'm not
Because
looking
we
at
decided years ago it was better.
No, but as long as you put them away during class.
Nope. There is literal research that says if you have your phone in your pocket and it vibrates, you cannot focus until you figure out why your phone went off.
Yes, so don't
Tell that to the
have it in
7th
class.
graders who kept like spamming us in an orchestra concert.
Yeah. So this, oddly enough, my Circumcenter comes out to be very close to my Incenter here. And that will happen sometimes. But then if I take my compass, and depending on how big your triangle is, your compass might not be big enough, go from my Circumcenter point out to one of the vertices, sorry. Not whoa, it's going to make a circle, but whoa, it hits all my, I fell off. I know. I don't have much space over here. You guys have more space than I do. I'm all like contained.
I only have my globe. You have such a big trip. It didn't.
Well, yeah.
It was off a little bit.
So my Circumcenter will make that circle perfectly
I see.
hit every vertice.
Is there like some sort of like computer thing where you could make the black and the white like contrast more? Because I wasn't able to put my contacts yesterday because I was sick, so I can't see that well today.
I would play with it.
Glasses to class sockets.
Oh, they broke.
Again?
No, they had been broke.
Do they have weird
Oh my goodness.
Okay, that looks like a satanic
Oh,
ritual.
that's cool. I like it. Let's just do the entire video.
It's very
inverted.
satanic.
Just to anoint it in. Let's do the entire video inverted.
I like how it's making red blue. So we have Incenter, Circumcenter, Centroid, Circumcenter. Now it's time for
What's the difference between
Incenter.
Centroid and Circumcenter?
What did we say Centroid stood for?
Center of mass.
Center of mass, and we made it with
Medium.
medians. The Circumcenter makes the circle's center, and it is made with perpendicular
Wait, so you just make the
bisectors.
circle by doing like that?
So they both, here's where they're similar, because that might help you. They both use the same midpoint of the edges. Where they're different is one goes straight to the vertice, the other is perpendicular. Now my triangle's pretty close to equilateral, that's why they're so close to each other. In an equilateral triangle, what do we think? Would your
They're all the
centroid and your
exact
ecenter
same.
be the same thing?
Yeah.
Why?
Because the center of mass would be in the very.
Yeah. The center of mass is the very center of the triangle because then it cuts it into 3 equal triangles again. All right, so then to make your incenter, and I'm going to do it on the paper probably just because I was too big. We connect what?
You do all the angle bisectors.
Angle bisectors. How did we say we found the angle bisectors yesterday?
There.
You do the median so you find where to.
You do an arc on the
Yes.
from
You make a
the
line.
point on the angle,
Yeah.
and then you
Wait, so how do
basically
you-
find the perpendicular bisector of the arc, sort of.
Oh,
It's
you
kind of
make
like
the arc
the
and you put points on where it hits the 2 sides, and then you put your compass little stabby thing
yeah,
on
that's a
those
better explanation.
And then you
Wait,
go,
so
I
how
use
do-
the term compass stabby thing. Jacob.
It's still better than my explanation.
So wait. Sorry, I need to put this up.
Wait,
Talk me through it because Satya had left the room at this point.
I did this.
Where do I put my
What is that?
stabby
It's
thing?
gonna be-
Stab
No,
on one
I'm
of the
difficult.
angles.
On one of the vertexes?
Yeah.
Okay.
The
And
shadows
then you
are
make
active.
it smallish.
Small-ish. Less than half?
Yes.
Wait, why are you doing
Make it
that?
less than that, and then make it
That's
arc.
probably about good.
What are you doing?
Then you make an arc.
Satya, can you stop freaking out for a moment and listen to the instructions?
And then you make.
And then you put the stabby thing on where it intersects with the line, where the arc intersects the line.
And then you make it slightly more than half of that. And then you
I
find the
got it.
midpoint.
And then what?
And you find the midpoint.
What do you mean? How?
You make an
it-
arc from there,
Yes.
and then
Where?
an arc on the other one. Although that's a little big.
Yeah, that's big.
be like halfway in between where the arc is.
A little bit.
Yes, I did it.
What do I do?
Smaller.
So good.
And then you make an arc with that.
Which way? Like over here?
No. No. We're finding the middle
Between
point. Like the stabby thing on there and then do it right, yeah, like there. Yeah.
so that it crosses your other arc.
Yes.
My other arc. I only have one arc.
Yeah, your other arc.
What if someone made glasses?
And then make it bigger
inverted?
on the other side.
Well,
On
this
the other
is
side.
so
What do you mean,
You
here?
don't need to make it a circle. No.
What if someone made inverted colored glasses?
So this is where sometimes a quick Google image is really useful.
That's just making me more
Find the
confused.
midpoint.
So
It's hard to explain.
You just find the midpoint.
Correct.
You know how to do
What
it.
did you do, Lauren?
Find the midpoint.
Someone
What did you do?
Is that the
here's where I was trying to like make them be really explicit and clear, detailed, and it just wasn't totally working out.
Yeah.
Wait, so you like find a way to make a circle that like touches?
So notice these they put outside the circle just to clean things up a little bit. What Thomas and Jacob were trying to get me to do is I made that arc from that point. All right, that's the same. And then if I do it from here, it's just that intersection point that I care about. Yeah?
The other one isn't really needed.
Yeah. 'cause
So if I try this again at B, I make an arc that intersects both sides. Yeah? Now that's kind of big, but if we follow what the other image, if I wanted to put this outside the triangle, I just stretch this to some length. I arc E out here, and switch points, and arc E out here. And then my straight edge, sorry that the focus keeps coming and going.
No, I just want to get a compass so I could just mess around.
Oh, I might get some really nice compasses for our math art class that we're doing. There's really nice compasses that,
And that's angle lens.
huh?
Yeah.
Yeah, angle bisect.
What do you do with that?
and you find the point of intersection.
If I can find it at some point, I'll show you.
Incenter.
Oh, here you go.
That's the Incenter.
Well, this isn't even that nice.
Centroid is-
There's nicer ones that have a wheel in the middle, and that's how you change the size. You have to rotate the wheel, and it actually like opens and
I
closes.
have one, but it's broken. The wheel doesn't do anything.
Yeah, I don't know if I have any that
And
nice.
then I have another one that the wheel's fake.
So then we do this again. Guys, please make sure you're doing this so you get comfortable. The constructions test is normally not an easy test for people. So I make my arc to hit both. Then doesn't matter what size, but I have to keep it fixed between these two steps. Outside the triangle kind of makes it easy. So I go outside the triangle, and then outside the triangle. Those match to here. So straight edge.
Do you have anything to do in extensions?
Me?
Yeah.
I have a meeting
Okay.
at 4:15. Excuse me, I'll be around till like 4:10. Come hit me up at break or something.
This is cuts on
Now,
the shady.
this point should be the point of concurrency, but I haven't verified it yet because I kind of goofed with A. But I have my two arcs for A already. Go through that intersection. And there we go. It hits. Now, from there, how we show that this is the incenter, put your compass point on the incenter, line it up with the edge, and then, I got bigger.
But not just any
Don't
old
do it.
edge.
Yeah, my compass won't stay the same size.
Your hands look beautiful.
Thanks. My compass wouldn't stay the same size, but that is relatively what you will end up with.
Wait. I don't understand. Hold on. Salty is catchphrase.
Yo.
Hold on.
I don't understand.
I don't understand. Hold on.
Hold
I'm going to do it again with a bigger triangle. It's trying to invert a gradient black white.
Yes, I did it. I did it.
Yeah, it doesn't know. It's just making it weird blue. All right, let's make an odd triangle maybe.
Wait, Mr. Hudson.
Yes.
Wait, hold on.
It's
So,
like a big triangle.
would I just like do that for each one?
Pretty big triangle.
Here, let's process through this again. Let's everybody make a new triangle. Because Incenter tends to be the harder thing. Here, move this so you have somewhere to work. You need your compass too.
These work.
I'm going to put all of these outside. So here, if you don't yet understand it, watch. One arcing from the vertex that doesn't have to go all the way right here. I could just make a tick here and a tick over here, but I could let it go all the way through. Then I could keep it the same size if I want, or I can get a little bigger to make sure it's big enough. I'm going to place this outside the triangle to keep things clean. Here, Sati, you can even look here. And then from the other intersection of that arc, same size, right? I got to keep the compass the same size. That gives me an angle bisector. A singular bisection of the angle.
And then you repeat this 2 more times.
Repeat step 8.
Keep going until you
I didn't
die,
do this
and then
right.
continue until you've done all 3 times.
Yeah, this definitely.
Wait, so what you do is. Mr. Hudson.
Mhm.
So I make this bisector right here. Wait, no, on this arc right here.
One arc, yep.
And then would I put
From where the arc hits the edges.
so right here?
A
I'd go
different
here
size.
to C.
No. Does not matter what size this is now. So you're coming from this angle, right? From B, that made B's. You now, if you want to keep it clean, put it out here. And you're going from the point where, now be careful because you got to keep it at the size it is, which actually I might need to tighten yours. You just grabbed them from the rack and they're not all. Then from the other point out to, so you don't need a very big one. From this point then,
The same thing. You just bad
so it
at lining
intersects out there. All we care is that it makes an intersection with this arc. So you don't need to draw that much. You just needed that point.
So then I find this line right here, and then I have an angle bisector, and then I do those
You
with
do
all
the
3.
same thing
And then
again.
where they all intersect, would that be the incenter?
In center, yep.
Okay, because I saw circles and I got confused.
You did it.
So I'm going to walk through this again, just for the rest of this. So from a vertex, we make a moderately sized arc. We don't have to hit like the whole arc. We just need these 2 points. Those are important.
Something like that. That's good enough.
Now, when I do this, I'm thinking, like, where am I going? This angle bisector has to go this way. So if I want to make this cleaner, stick that arc out here, and the other arc will intersect it. That's all I need to show.
Is this unit all constructions?
811. 821 changes gears, and that's why I changed our schedule this week how I did. So we would continue this today, deal with the other stuff tomorrow. I have another angle bisector. That should be my incenter, but don't trust it. Verify it. Big arc. Well, moderate arc, sorry. Then, now this isn't gonna, well, I might be able to stretch it out.
No, it didn't work.
I stretch out to here,
I went too far.
and then out here. Those intersect. Straight edge. Now notice I'm slightly off, so my compass changed size somewhere and kind of got goofed. So I might infer that the point is in the middle of those. Yes.
Do you have big paper I can
What do you mean by big?
I don't have enough
Like just computer paper?
computer paper.
play with this.
Mr. Hudson, I did one with all three.
So that then is your challenge if you want, is to make sure that you know how to do it. Those inverted colors are pretty crazy.
The shadows are really cool.
Now, if that point is right, which we're doing these manually, you can also do these on a computer, like using CAD or whatever.
Yes. Get it right.
What's CAD?
Computer aided design. So that's just like a CAD tool is like a computer aided design tool.
I did it good.
I'm not doing it good.
You're not doing it.
You're doing it gooder than me.
Yeah. The gooderist.
The what?
I also stabbed through my paper and now it's moving.
That would be a really weird thing to say.
Alright, it was close.
Yes,
I almost did it.
commit self-necrosis.
I would like you to perish. Hello there. Please perish.
Alright, questions on the Incenter.
Yeah, why are the circles? The circles confuse me. See that
The
giant
one in the middle or
Why would you make a circle?
It's an insert.
This?
It's a circle
It's-
that goes to the middle.
Yes, the circle that's like from the Incenter. Why would you do that? What's the point?
I promise you it will all make sense as we continue on, but to give you a tidbit of why we do this, this, and this, well, more so this or wherever you go, are now what's?
Congruent. They're the same. The radius.
If I drew it right, now my compass kind of got off, but I can now make radii and the relationships that we can start to see here, like we're going to continue to use this. The why do we do this? I can't teach you the why before I teach you the how. Right? Like it wouldn't make sense. So this is how we create the Incenter.
I think I understand all three of these now.
And if you don't, that's why the math notes box is there.
Woohoo!
Woo!
Circumcenter is pretty easy. Centroid
All right.
is pretty easy.
So,
It's all pretty messy to put them all on.
also this lays out step by step by step to do the Incenter.
But I know how to do it. I have to figure it out. I'm a super genius.
Are you sure about that?
Instead of writing this proof out, which we might do someday, I'd like to get your tests back in your hands and go over them. Yeah, actually, we have like 13 minutes left. All right, so
8. So we won't need a book anymore?
correct.
Steven, I got them out, you put them away.
Lauren, put away everything.
The books?
I'm putting away the compass.
You put away the compass.
Okay, put away the compass. Put away the books.
So what I found interesting was while we were taking this assessment, you guys were like, "Why are we doing so many problems of the same type? This is just," and like almost everyone made mistakes.
We messed up.
Yeah, we all messed
Oh, I caught my mistake. Even though I made like I'm guessing I made a bunch.
You caused me.
So remember, the grade that we are going to give ourselves is on first time through trying to show mastery of special right triangles. Did I effectively show that I know how to use those rules and find those unknown sides? If not,
I already know
we're
how to press
probably
it.
not masters.
I got $5.
15 should have been.
Oh, I thought I got the octagon thing right.
Here was the
You know,
biggest.
you set it up here, but then I know how to fix all the ones that I messed up.
Yeah. I don't. Hold on. Sorry.
That one.
10,
Easy
50.
to fix. That one.
Easy to fix, easy to fix.
So guys, you know what we talk about? Trust what is shown, not what you like, not what it looks like. Here, 30-degree angle goes to what looks like the shorter side. But here, the triangle flips, and the 60-degree angle's at the top.
So dumb.
I really shouldn't show you all of Midden's answers.
I got A wrong because I wrote 733 because I
I don't
didn't.
understand why I did this.
It should have been 8 and 16.
This
That
size
was dumb.
for 2 3.5 and 6, and I decided
No,
to
this
take
was
what
the
I
shortest
thought
side.
would be 5.
Never mind. Yeah, this should have been.
How did I get 5?
Are there any specific questions as you look through your test?
Or
12.
11.
Okay, let's be more systematic.
Oh,
On the front page, 1, 2, 3, 4, all special right triangles. Any questions there?
You put an X next to one of my answers,
Oh wait,
but you...
no, I wrote it wrong because you put the wrong thing.
Wait, no, never mind. No questions.
On the next page,
No.
5 through 8. And I don't really want to help you with the I don't really want to help you with 8 because I'd like you to go back and look at that on your own.
Yeah. It was just a 60, 3, wait, that's...
I think we all got 11. I think a lot of us tripped up on either 9 or 10 on at least one of them.
Yeah, I got
Let's
9.
go back and re-verify. But if we look at 12, we have a regular hexagon.
Wait, you got 12 right? Yes, so 5, 5.
Now the first thing I would advise is to do what?
Split it up into 6 different.
Yeah, you split it up into 6 different...
Split it into
No,
triangles.
you probably did it 5 times.
The difficult part is figuring out.
I did the multiplication wrong.
Trust me, it's not actually.
Oh no, wait.
It might have seemed like it, but when we talk this through, you're going to be like, oh, what? Oh.
Isn't it 10? And then everything turns out to be the same.
That has to be
Yeah, every single side on that is 10.
Yeah, we know it's regular, so I'm just labeling the one.
I did it
Well,
wrong.
I
I got it wrong because I was
something-
using radians.
So, hold up.
D10
I'm going to
is
throw
wrong.
questions at you.
Yeah, I know.
How-
What did I do wrong though?
How far around is that? 360.
No, that's.
Wait, no.
You're not looking.
Oh wait, no, I was reading all of
So how big is this?
16.
So how big is this?
30.
So we've created.
I had to search. I had to search on the day before I
Reg.
like the first day just to look at this, and I figured it out.
How does the long leg compare to the short leg in a 30, 60, 90?
It's 5 radical
It's
3.
5 radical 3 and then 10.
So 25 radical 3 times 6. It's 150 radical 3. Is that the entire?
I did 10 radical 3, not 5.
Oh, I
Wait,
somehow.
what?
Is
Oh,
there
I
a
got
10
to divide
radical
by two.
10 radical 3?
Sorry, there's a
I
half in
figured
there. I
out what I
forgot.
did. I
Is
forgot
it
to divide by two.
Every triangle,
Triangle.
Or
every one of
is it 150?
these
Yeah.
has a base of 10, a height of 5 radical 3, and we gotta use the half. A couple of you, I think, forgot the half.
I didn't even write it correctly. So.
A couple of you forgot the half.
Wait, what did I do? Okay.
You can do this in any regular polygon, but it won't always come out to be a special right triangle. Sometimes we have to use the trig.
No, dude, the most efficient thing is a square, so the most efficient thing. Remember we learned this? Like, remember that?
What else?
yeah.
On the back, some people struggled with 13
Oh,
and
yeah.
14.
How did you do 13?
Or no, wait, hold on. For this. Wait, can you go back? Since the 2 triangles that you made are the same triangle.
Yeah, you can just do 12 of those.
Or you can do
Did you forget
6
your lunch?
of
The
5
little,
times
yeah.
5.
Did you forget your lunch?
So would that just be 150 radical 3? Or, yeah.
What did you do? How do we do 13? Oh, I know
You
how
watched
to
too
do
much
it.
Do I know how to parallelograms?
Yeah, I just calculated it wrong.
No, like I know what I should have.
Oh, yeah, yeah.
Still don't.
Dude, how did you get
Somehow
3
calculated it wrong.
Dude,
Wait,
it would be 9.
For some reason, I just
Hold on.
Okay, so each measure, each
Okay, if it was a square, it might be easier. So that would be
2 congruent.
Half of
No,
that would be
no.
3. That would be 3. That would be 3.
No, dude,
It
each
would
side
be
was 6.
9.
Each side was 6.
Yes, this would be 3. I'm
How did you get that wrong? What did you do to get that?
I don't know what I did.
6 squared plus 3 squared equals. What are you doing?
Oh my god. I tried to do Pythagorean, but I did 8.
You're dumb. No, you. You can't correct it on the text. Back up. Wait, Mr. Hudson, do we need to do corrections for stuff like?
If you do corrections,
Chris,
it asks
please
you-
stop. I just can't focus.
How did I get 3 points?
Wait, Jacob, which one did you get wrong?
Oh, did you do the opposite? What's the area?
I got 571.02.
I got 123.
What can we start to figure out?
290.
Drop in
Figure out-
altitude.
Well, we know the congruent sides are 29, not 20, 26.
It's an altitude time.
Yeah,
you-
26.
The triangle.
Well, we can already.
This looks kind of awkward.
Yeah, that's the
compared
also
to-
looks like an
Wait, we don't even
isosceles.
have to
It's
know that.
because how the computer made the parallelogram.
We don't even need to know that though. We can do it a different way. We can find the area because it's a trapezoid. It's a
Oh,
trapezoid.
those two are the equal.
So this is
no.
technically 10 and 10
Yeah,
because this is technically an isosceles. My parallelogram looks weird.
and I got the angle measure of 22 for the
So we can just have it be. Just E.
How?
No,
Oh,
it's-
it's a trapezoid.
Oh, this one is so easy.
30, 60, 90.
Now are we sure?
Oh.
Isosceles being 30, 69. Equilateral
No,
for
we
sure.
just split it in half.
Okay. But isosceles is just two legs the same. Is that
Here, wait. Can I
30,
come
69?
up for a second?
Yeah, always.
So I can show what I did, or at least what I think I did. I'm not really sure
Oh.
what I did.
What did I? Why did I not?
But so
I don't think I should.
You come up and you can get the whole area in the trapezoid.
then radical 2 times radical 2 is 6. Then you should have gotten 10. So then, how did you even?
Where did I put my?
So then even if that is
You
what you
don't know
did,
the
you
height.
would have gotten to what I
You
did.
gotta do the height thing.
And I did that wrong, so it shouldn't be
So
6,
I
shouldn't
did
it?
it on this.
It's radical.
Chris,
What did you even?
Yeah.
Okay, so you should have gotten
You're
that wrong
making
too.
this, I think, harder than you need.
Yeah, probably.
There's a
This is
reason
trapezoid formula, isn't
we
there?
taught you trigonometry.
I did.
Yeah.
Aw.
We could have used tricks.
Step back for a second.
Wait, Jacob, which one did you get wrong?
We have.
I mean, I got a couple of them wrong, but I've already redone them because
I hope that
Wait, can we do them on the
even if
test?
your way worked, I hope that you realize there's a different way.
Yeah, but you still have to. Wait, Mr. Hudson. Can you redo them on the test?
Yeah.
No, separate sheet of paper.
Oh.
Hot algebra.
Yeah, every time you've done that this year, I have, when I gave you your paper back, said next time I need this on a separate sheet of paper. We're in semester 2 now. I'm no longer going to accept when people just straight up don't follow directions. So I have a leg and a hypotenuse. And the leg, if I want to determine this angle, is adjacent. Right, so if I set up cosine of an unknown, or theta, whatever I could say, adjacent over hypotenuse, right?
This feels
Inverse cosine.
unnecessary.
Well, that will let me find my height.
Wait, did you get?
So if I don't know my angle, then I can't figure out my height. If I know my angle, I can figure out my height. There are multiple ways to do this. But if we want to utilize the fact that we know trig works, inverse cosine of 1026 will give me my angle z. As soon as I know that angle, I can figure out my height.
Isn't that angle? Wait, what's
Inverse cosine of 1026, you could figure it out as quickly as you could ask the question. The inverse cosine.
Yeah, I thought this wasn't. I thought this was an size.
It is isosceles.
Oh, it is.
You still don't know the size of the base angles.
Oh yeah.
It would just be 90. It would just be 90, 90, and 90.
So I did inverse cosine of 10 over 26 and I got 1.17. Does that seem right?
No,
What do you think I need to do?
degrees.
Switch my mode. Your base angle comes out to be 67.4-ish. Now again, this is if I was solving. There's multiple ways. There's and now that you're deep in math, there's almost always multiple ways to do this. So then if I want to find the height, I can still use my adjacent, but then I could use my opposite, so that'd be TOA, right? So tangent of 67.4 equals opposite over adjacent, so my height over my 10. So 10 times tangent of 67.4, 24.02.
I got 23.99.
Yeah, it's probably my rounding. Because I rounded 70 or 67 point, I rounded that off. So approximately 24. Right around there for your height. I rounded my angle, so that's why I'm saying approximately. I didn't use the exact.
Use 10 and 24 and just do square of 10, and then the equal plus that line squared equals.
Yeah, we could use Pythagorean there too, right?
Yeah. And it would be.
So if I did 26 squared minus 10 squared, I guess that might have been why you all were thinking I was stupid. I just like trig. To be honest, I really just like trig. So 576, we got to square root that. Yeah, exactly 24. So if we use the Pythagorean, we get the exact height of 24. And then that's going to be your height here also. And from there, it's just a little bit of solving. That is all the time we have. So have a wonderful day, guys. If you think this is mastered, put it on there, turn it back in. If you think it's progressing, fix it, turn it back in.
I got 4 wrong stupid mistakes. And then I just revised them in 5 seconds. So should I put progressing and then just give you the revisions?
Yeah, I mean, you could put P fix for M or whatever you want to say. Like, when there's silly mistakes, I normally just tell people to fix it for mastery.
See, I demonstrated mastery of the topics, but